we'll focus on 5, obviously, here. Um, it has the little calculator next to it, which I'm very much against, because it totally defeats the point of this problem. If you can use a calculator, then there would be zero reason to even try to do anything by hand on this. So we're basically trying to pretend that we do everything by hand until we get to the point where we need a calculator. I get it's very a hypocritical catch-22 type question, like the fact that we're using a calculator defeats the whole point of the whole unit. But we'll go with it. And I thought this would be a good opportunity to go over how to use the calculator, because I definitely could tell the last unit, when we needed it, a lot of people forgot how to. And we just don't get to use the calculator enough to ingrain it into you, so I thought this would be a good opportunity to do this again. So we're going to have a lot of volunteers today. This is how I call on people. We have James. Wait. Yeah, James. Couldn't tell if I wrote a 2 or a 3. Says the graph of y equals x squared minus 3 plus sine 2x minus 1 changes concavity on the interval. So we have to figure out how many times that happens. How do we go about finding that? That is the perfect answer. So come up and find the derivative. And you have lots of people to help you out if you want some help. Yeah, I know, it's not really a good route. And concavity is all about second derivative, so we've got to go all the way to the second derivative. Times 2. There you go. Chain rule it. Okay? FYI, since we're using calculator, there's no need to simplify anything. You can just type it directly in the calculator however you get. Yep, we need second. Like if we're doing product rule or quotient rule, there's zero reason to simplify it because you can just type it in as you get it. That's perfect, but I'm kind of more interested why you write your x's like that. It's almost like 2 C's or something. Nothing wrong with it. I was just curious. Derivatives are perfect. Okay. Anybody? Well, wait, what? Oh, I wasn't even. Let's be real. I wasn't actually watching. Yes. Sorry, it would be a 4. Because you do the chain rule twice. For the first time, well, from the first derivative you get a 2, and then you multiply by another 2. So here, I will show you how to cheat like a teacher. 4. That way you can never even tell what you wrote. Aman, you're 15. What do we do next?
Set it equal to 0 and find the zeros of it.
Ava, what were those called?
What?
You're the expert.
I'm the expert. They were the inflection.
Oh, come on. She's the expert.
I can't think of the word.
Possible inflection points.
Yeah.
So you're the expert. You got to know these. Everybody's going to call on you for backup. Possible inflection points, unless you just want to call them pips. Okay. How are we actually going to do that, though?
Set it equal to 0 and then find the
Yeah, they're like, how do we do that? I mean, I can write equal to 0 too. I was just, how do we solve that?
Like the algebra, then
I'm just letting you be the teacher.
you
We're pros at this by now.
subtract 2 onto the other side, divided by -2. So that would be -1, and then,
-4, I think he meant. He wrote down 2 originally, and
oh
I wasn't. Yeah.
That'd be -4, and then,
So you're telling me how to solve it by hand?
yeah.
Oh, which is 100% correct. Also a lot of work, especially when we're told to use calculator. So how do we do this on the calculator? Lucky for you. Here you go. I was hoping you could come up here and show everybody how to do it. That's the same as the one you're holding in your hand.
I don't know how to find the zeros on the calculator.
Well, then why were you holding your calculator in your hand?
Pull it up there.
You were just using this as a demonstration to be like, you do it here.
Yes.
Oh, well, that's not going to help anybody else. Oh, dang. Do you want some backup, it sounds like?
Yeah.
He's looking for backup. We need an expert in here who can solve these on the calculator. Oh, gotcha. Yeah, it's slightly different. It's not terribly different. Buttons are in different spots. It's pretty much the same process, though. Are you telling me nobody in here knows how to solve that equation equal to 0 on the calculator? I know, I just showed somebody yesterday even. Yes.
Thing on the calculator where you could do it like this.
Is that the solver?
Yeah.
Yeah, we're definitely not using that.
Does that work or no?
Sometimes it does.
Sometimes it doesn't.
Correct.
Okay.
It shows the answers differently sometimes as well. So it's not that it's not that it's wrong. It's just it's kind of almost made more for the science class. I think so.
But it still gives me an answer.
Well, I do, but I don't know if you're going to like where the answer is. It is the chord on the solo cups. So you could take it apart and use it. Okay, I will show you on the first one. And I'm kind of expecting you to be able to do it on the second one because this is something we've done a bunch. First thing you traditionally want to do is put it in y equals. Oh, I had it there. What happened to it? 2 minus 4 sine 4 sine 2x minus 1. Oh, whoa. Now, when you put it in y equals, that is you telling your calculator what equation to be used for a variety of things. Putting it in y equals is not just for graphing, it's for a lot of different things. Calculator needs to be in radian mode, so I would double check that. Mine's in radians. If yours is in degree mode, your graph usually looks like a flat line because it's stretched out 360 times wider. Well, I guess not 360, but whatever. Whatever 360 divided by 2 pi is. So I'm going to hit graph. I get that. Aman, do you want to answer this part, or do you want me to pass it on? Okay. So glad I bought a new roller. Oh, here, I thought it was rolling right back. That's I. 18. Patrick, how do I interpret this? What did I just do?
You graphed it.
Okay, so how do I get answers from that?
You gotta find the 0 or the intersection from.
Okay, so the zeros is where it hits the x-axis. So if we're trying to make the second derivative equal to 0, it's where it hits the x-axis. Does anybody remember how to find that?
You go to second and then you go to cal.
Good. So above the trace button, it says calculations. We want the zeros. Number 2. Okay, now it tells us a bunch of stuff. Charlie, you're 27. What do I do now? Like it tells me left bound. What does that mean? You don't know? You might know. Can you just tell me what to do from here? Oh, okay, yeah, you're just trying to answer the big question. I was trying to ask, what is the calculator telling me to do? Does anybody know what it means when it says left bound? Because these are things you guys need to know. You can't just like memorize button pushing because it won't work. You'll forget it all the time. And clearly that has happened. Oh, go for it.
Don't you just put it to the left and 0?
Correct. Left bound means it wants to know where the left side of where it should look. You're telling the calculator where to look. Because there's a lot of zeros on this picture, it needs to know where to look. So left bound means it wants to know the left side of where to look. So I'm going to move it to the left of the 0. That's the left bound. When you hit enter, you should get a dotted line. Are we okay with that? Doesn't look like it. Now it says right bound, which means it wants you to put the cursor to the right of the 0. And you should get another dotted line. My 0 should be in between those 2 dotted lines, and it is. Now, I don't know why it asks you to guess. You shouldn't need to do this step, but it has you do it. Put the cursor about where it crosses, and then hit enter. And it tells us our first 0 is at 0.762. What the heck is this thing? Did it go in the garbage? Oh, that is disgusting. It's right on top of somebody's Kleenex, so now I got to decide if I want this ball back or not. Oh boy. Genius move here. Let's get a Kleenex to pull it up top of a Kleenex. It is. Not sure if we're ever gonna. We're gonna have to sanitize this ball. 24. You have a tainted bingo ball. Sahi. We have a tainted one here we got to work with. We're gonna. Let's pause. Let's disinfect this and me. Okay, Sahi, what I was trying to get at. How many answers are we supposed to work with up here? Like, we just found one answer, but there's a lot on the screen. Are we going to answer all of them? Perfect. Only 0 to 2 pi. So we are only going up to 6.28. So it looks like the next one is just a little bit over. Okay, so I'm going to go right straight back to 0. And now I'm just going to have to repeat this process for the next spot. And this is clearly an annoying process. If you have an Nspire, which I think some people here do, The Nspire, you should just be able to use the trace feature and it will pause at zeros for you automatically. So you don't have to do this step. The Casio may or may not. I don't know if it does that. You have to find zeros separately, I think, too, correct?
Yeah, we actually just have to trace.
And it'll stop at the zero?
It won't stop at zero, we get super close to it.
Then that is not correct.
0.00 to 0, and then 1.
That's a bad move. Don't do that. Yours has a spot for zeros as well. The Casio has a feature for zeros. Okay, our next zero, 1.809. And then I'm pretty sure yep, that'll be an answer. This will be an answer, and I think this next one's too far. Yep. Okay, so we're going to have two more answers, right there and right there. And I'm going to not find the last two and use up a ton of class time just to find those two. But that's how you're going to have to do it. So this one would have 4 solutions. It's telling us that we would have 4 inflection points. Actually, no, it didn't ask that. What did it ask? It just concavity intervals? Okay, so it would be concave up on this first part. Actually, that's a good question to ask somebody. Ian, how do I know from 0 to 0.7 something it's concave up? I think the first 0 was 0.7 something, wasn't it? Okay. How do I know that that interval is concave up? By looking at this picture. This picture tells me that it is concave up from 0 to 0.7 something. What graph are we looking at? We're looking at the second derivative. So how do I know it is concave up from 0 to 0.7 by looking at this picture? No. Too complicated. Definitely no. Did you whisper the wrong thing? Does anybody know this answer?
Because the second derivative is, it's decreasing there.
Mm-mm.
Or it's like a number decreasing there, which means
Oh, wow.
it's concave.
Yeah, you guys are overthinking this one.
Isn't it just because the y value is positive?
Yeah. So the graph is above the axis, which makes it a positive answer and a positive second derivative. This is the second derivative graph. So you're not supposed to look at the curves and things on this one. This is telling us the curvature of the original function. So above the axis means it's a positive value, which would be a positive curvature on the original function. So I know it is going to be concave down on this little section here because it's below the axis. Concave up on this big section. Does that make sense? You kind of remembering these details? The y is 0 on the second derivative, which would be an inflection point on the original function. Yeah, let me change my window. We'll do 0 to 2 pi, which we absolutely could have done to start, and that would have helped too, but this section right here is above the axis, so that means the second derivative has positive answers, which is concave up. Okay, let's go to problem number 2. We should be better at this now. I tried taking a long time on the first one for that reason. Okay, using a calculator, find the values of x at which the graph of y equals e to the xx squared changes concavity. Who did I call on first again? James, yeah. So you said find the second derivative. Okay, we can do that manually. Do you guys know how to find the derivative on the calculator? So, on complicated equations, it might not be beneficial to do it by hand because it would be slower. Would you like me to show you how to just type it in the calculator to get a graph of it? Because we don't actually need to know what the second derivative equation is, we just need to know the information. So you can find the second derivative by hand. It will work fine. It's just annoying because once you do the product rule for the first derivative, you're going to have to do 2 product rules for the second derivative. It's not terrible, it's just annoying. Now, if we felt like being lazy, aka efficient, well, then we'll have the calculator do it for us. So it was e to the x squared. There's my first original equation. If I want my calculator to graph the derivative, I'm going to sort of cheat. So your calculator can find the derivative at a single number. And I'm going to tell it to do that. So I'm going to go to nderive, wherever you like to choose the button from. Is there 83s in here? I can explain on 83 if somebody has one. Okay, so d dx, and then I can retype the original equation if I want. Otherwise, I'm just going to put y1 because that's the equation. So if I go to F4, that's where I can find y1. And then instead of me typing a number there, I'm going to cheat and tell it to do it at every single x value. And if I hit graph, it'll graph the first derivative for me without me knowing the equation. And then if I want the second derivative, I just repeat this process, but tell it to find the derivative of equation 2. Go ahead. Do you want me to just erase y2 and start over? I'll do that. Okay, we want to type the derivative. Are we at that step? Nderive. You can get it under the math button, or you can go to F2. These are supposed to be the logic skills you guys are good at, right? Logic tells us that if we can do a derivative at one place, we can make it do a derivative everywhere. Were you guys trying to ask where I got y1 from? There's 2 locations you can find y1. Do we get done at 15? Oh, we're not even going to get 2 questions done. Oh, wrong day. Okay, yeah, 29. Good. Y1 is in 2 spots. One spot is under variables, because this is the button to where every variable in your calculator you can find. And we want a y variable because it's y1, and it's a function, so I can find it there. That might be easier to remember. The variables button. It says vars. And then I want it at every x value, not at a single number. So I just put x. Yeah.
That's a really big coincidence. I was outside of the room. I was, and I didn't even know she was gonna go. That's a really big coincidence. That actually isn't that. I guess just.
Let's just say one of you at once, at a time.
Yeah, I'm taking a test. Okay.
I don't even remember where I was now. Are you guys okay with this line? Did you get that part figured out? Okay, if we want the second derivative, we're going to do the exact same process, but put y2 in here, because that would be telling the calculator to find the derivative of equation number 2. So every one of these buttons can be found in multiple places. See, this is what I used to do when I was bored, is I would play around with the calculator and find what stuff was. And now I know how to do it when I'm older. Actually, it was a totally different calculator, though. Pretty much this is how you guys learn stuff, is you play around with it. It's just the same as when you got a new phone, new tablet, new computer. Play around with it to find things on it. If I hit graph, it's going to take forever. And that's because it's manually calculating the derivative answers all the time. I don't want equation 1 and 2 to be graphed. So I'm going to go hit enter on their equal signs. And it won't graph them. The ones that are highlighted, it graphs. Mine goes quick because it's the computer and it can actually calculate it a lot faster, right? Yours has a computer chip from the early 80s. It goes a lot slower. It's literally the computer chip from the Apple IIe, the original Macintosh.
Okay, so which one, like how do you make it so it doesn't graph?
Move the cursor to the equal sign, and if you hit enter and it unhighlights it, it won't graph it.
So we only want the line 3.
We are only interested in the second derivative because we are trying to find out information about inflection points and concavity. So looking at this graph, does it only cross once or does it cross there? I can't tell. Let me look at the table. That doesn't help. I forgot I've got it on table on menu. Yeah, it only crosses the once, it looks like. So it looks like right there is going to be our only pip, our only possible inflection point. I don't even know what this question was asking. Find the value of x at which the graph changes. Okay, that's exactly what we were looking for. So I want to find that answer by doing the 0. And apparently the answer is negative 0.586. Okay, just my gut feeling here. You guys seem like the calculator is kind of a totally foreign subject still. Probably accurate. So as you are doing the homework in this section, I would do everything with the calculator after you're done with it so that you learn the process. Because you're going to have to use these same things throughout lots of different topics as the year goes through. And then when you're taking the AP test, half of the questions are designed to be done on calculator. So you're going to want to know where all these buttons are. I mean, like, even if you know how to do a question, if you don't know where it is on the calculator, that question becomes very difficult to do. So I would practice using the calculator on a lot of these questions in the packet, even if it tells you not to, right? Just to practice doing it. Now, there's one topic left that I didn't necessarily want to do today. I figured I'd do it tomorrow at the beginning of the hour. Why don't you guys, while you're here for the next 15 minutes, like the first 3-4 questions in the homework, whatever, specifically try doing them on the calculator. Is she back? Oh, then why would I do it? Could if I was watching. You can check, yes.